Okay guys, today we're going to talk about inverse from tables and graphs, so a continuation of inverses from yesterday. So we'll start with this first example. It says function A contains the points 4, -7, 5, -15, 6, -18. List the set of points for the inverse of function A. So if you remember from yesterday, if it has inverse from that table from your first example, we're going to switch x and y. Okay, so basically we will rewrite this. So instead of 4, -7, you're going to write -7, 4, -15, 5, -18, 6. And that's listing the set of points for the inverse of this function. So whether they give it to you as a list of points or whether they give it to you in a table, you're always just going to switch your x and y values. Okay, our next example says find the inverse of relation M. So here's our relation M. Graph the relation M and its inverse. Determine if the relation and its inverse are functions or not. So this time they've given it to you in a table. So if we're going to write the inverse, again, we're just going to switch x and y. So I'm going to bring this over and write 0, -1, -1, 0, -1, 1, and -2, 2. And then we'll go graph. So I'm going to label this graph relation M, and then this would be the inverse of M. Okay, so you know how to graph coordinates, so we're going to go find the point -1, 0. We'll graph that. Then 0, -1, 1, -1, and then 2, -2. So that's what that relation looks like. We're not going to connect any dots. It didn't tell us to do that. It just said graph the points. So if I look at this, it says determine if the relation and its inverse is a function. So would this be considered a function? Well, you're going to look at that by doing the vertical line test. So if I drew vertical lines down through here like this, you can see that it's only touching, the vertical lines are only touching one point at the time. So this is a function because it passes the vertical line test. And I'm going to put VLT for vertical line test. Okay? Now let's graph its inverse. So 0, -1, -1, 0, -1, 1, and then -2, 2. So there's the inverse function. Is this going to be a function or not? I said function. I shouldn't have. No, it will not, because if you look right here, this vertical line goes through 2 points at one time. So this is not a function because it fails the vertical line test. Okay? Alright, so example 3, get this figured out here. Example 3 says, given that g of x is 1 to 1, what is the value of the inverse of 3? So if it's 1 to 1, if we recall from yesterday, that means it has an inverse because it passes vertical line test and horizontal line test. Okay? So what I would do is I would just make me another table for the inverse. And we're going to flip these. So 3, 1, 4, 2, 5, 3, 6, 4, and 7, 5. So if you think about this, it's usually like this, g to the negative 1 of x, or the inverse of x. So 3 is replacing the x. So if I go to my inverse table to 3, my answer is going to be 1. Okay? So another way you could look at this, if you don't want to do the table, if you can remember that you're switching your x's and your y, if it's asking you for the inverse of 3, that is really the y value in the original function. So I could come here to the y value in the original function and get the x value for 1. So either way would work. If you get confused, make the table, flip your coordinates, and go from there. Alright, so example 4 says the graph of the function f of x equals 3x minus 4 is shown below. So here's the graph, and I actually went ahead and put the couple points on that line that I could tell were accurate, and we're going to find the values of those points. So if you remember, you could do a table, so I could find these points. So let me do a quick little table here. So this looks like negative 1, negative 7, 0, negative 4, 2, 2, 3, 5, and 4, 8. So that's points on the original function. So the inverse, so this would be the inverse, we would flip all those. So negative 7, 1, oops, negative 1, negative 4, 0, 2, 2, 5, 3, 8, 4. So now this means inverse. So you would need to look at your inverse table, go find 5, so your answer would be 3. This means inverse when x is negative 4, so you would go to negative 4, your answer would be 0. For 2, you would come here, same value of 2. Again, if you can remember that this would have been your original y value, you could have went to the 5 on your y-axis, over to the function, down to see that your x value was 3 at that point. But if that confuses you, make your table and go from there. Alright, so I've got a couple your turns. So here is the points that they've given you. They want you to find the inverse of 6 and then the inverse of x when x is 1. So I'll give you a minute to think about that. So the first thing we should think is flip these coordinates. So we're going to have 5, negative 2, 6, negative 8, 1, negative 4, and 9, 1. So now, because this little negative 1 means inverse, I'm going to look at this table, or not table, list of coordinates. So I'm going to go find where x is 6, so my answer is negative 8. Here, when x is 1, so I would come here to when x is 1, so my answer is negative 4. Okay. On example 5, we're actually going to graph the inverse of this function on the same coordinate plane as the one that we have. Let me get a little bit of a brighter color here. So again, what I would do is I would make a table of values for my original function based off of the coordinates that you can see. So here, let me try to make these bigger so you guys can see those. So at this coordinate, we're at -7, -5. Here you're at 0, -3, 3, 0, and then 5, 7. So inverse means switch x and y. So let's make our inverse table. Switch x and y. And then we're going to graph the inverse. So we're graphing these. So let me change colors. So I'm going to graph -5, -7, -3, 0, 0, 3, and 7, 5. And then you're going to do your very best at drawing the inverse function. So we'll do something like that. Last, it's your turn, so you would graph the inverse again. So it's not always a reflection, so don't think you're just going to flip this parabola over. So let's make our table of values again. So there's a point, there's a point, there's a point. So here's our function. So I've got -2, 3. I've got -1, 0, 0, -1, 1, 0, and 2, 3. So then my inverse is going to be 3, -2, 0, -1, -1, 0, 0, 1, 3, 2. So we're going to graph these coordinates. So 3, -2, 0, -1, -1, 0, 0, 1, and then 3, 2. So this time, that's what the graph of the inverse looks like. I would do the same thing on the last example. Find you a couple coordinates. In this case, there's 3 easy ones to see. So you got 0, 0, 1, 1, and 4, 2. So your inverse still have 0, 0. You'd still have 1, 1, but then 2, 4. So 0, 0, 1, 1, but then 2, 4. So this one would come something like that. And that's how you find the inverse from a table and a graph or a list.